Hi guys. So in this video, we're going to be going through the topic of working with time. This is the one where you're talking about like time differences, longitude, latitude, and all that stuff. So let's go into syllabus points first of all. So we first need to indicate the positions on the Earth's surface, specifically looking at latitude and longitude. So this latitude being north-south, and then longitude talking about east-west. All right. And then we have coordinates. So you have, something north or south and then something east or west. So the way that I remember which one's latitude and which one's longitude, remember our coordinates are something north or south and then something east or west, right? So it's north-south first and east-west second. So that's pretty easy to remember. And then, so knowing which one's latitude and which one's longitude, I think of it as alphabetical order. So latitude and then longitude. LA comes before LO. So that's just one way of remembering whether which one's latitude, which one's longitude. I mean, you could just remember it anyway, but that's one way of doing it. And then understand and use the link between longitude and the time to find time differences. Now, this is an important bit that is often overlooked, and I think part of the reason for that is because it's not in the textbook as we're going through it. The reason why it's not in the textbook is because this was a late addition to the syllabus, and so therefore it was added into the syllabus after the textbook was written. But I'll talk a bit more about this as we go down a bit further. But there is based on the difference in longitude, you can find out the time difference between places. Other than that, going on, so we need to be able to convert between 12 and 24 hour, understand the link between time and it's interesting that they have the same syllabus point twice, kind of just emphasizing how important it is, I guess. And then talking about daylight savings, UTC or Greenwich Mean Time, find the time differences between two places using the international time zone, interpreting timetables, and then solving practical problems, involving like travel time, calling people on the phone, all that kind of stuff. So let's focus next on the reference sheet and the formulas. Now, there's actually nothing on the reference sheet about this topic. There used to be on the old syllabus because there was a lot more to this topic, but they've kind of trimmed it down a little bit. This was on the old formula sheet for general maths, and I've just added it in here because, again, it's really important that we understand that 15 degrees of longitudinal difference, so the east-west, that accounts for 1 hour of time difference. So again, just to emphasize, that's not on the reference sheet anymore. My theory is that, as I was talking about a second ago, that used to not be in the syllabus, but then they added it into the syllabus a little bit later. And I reckon if it was originally in the syllabus, this would have been on the reference sheet. And who knows, maybe next year it will find its way on the reference sheet. But for now, it's not. So you just need to remember that every 15 degrees of longitudinal difference accounts for 1 hour time difference, which is useful when you're not given the time zones. And then lastly, so talking about the frequency and difficulty, what I'm saying here basically is this, the kind of question that you could be asked is, find the time difference between two different places given some kind of situation. And it might give you the time zones. So it might say this is UTC -5 and this is UTC +7. And then you can find the time difference between that. Or it might just give you the longitudes like it did in the 2021 CWSA trial exam, where it just gave you longitudes. You need to find that difference. And again, use this idea 15 degrees is 1 hour time difference. It's also just worth noting as a side note that in at least up to this point in 2021, who knows what 2021, but 2020 and 2019, the HSCs actually didn't ask any questions about this topic. That's not to say that's not going to be in this year. We just don't know. But it was in each of the trial exams over the past 3 years. So, and I think it's not unreasonable to expect a question like this. So just a few things before we go into it. So as we talked about, latitude is north-south. And it's worthwhile talking about the limits of each of the different things. So remember, latitude is, here's the Earth, and we have the equator. So what latitude is if we have like some points on the Earth's surface, and then we drew a line that went right into the center of the Earth, and then we drew another line from that center of the Earth to the point immediately under it on the equator. The angle in here is what the latitude is. So because this is north of the equator, so say that this is like 20 degrees, okay, we would say that this is 20 degrees north because it's north of the equator. Same thing here. Say we had a point, down here or something. So again, we consider like a point here, which is directly above it on the equator. And then, so maybe this was 30 degrees. So we'd call this 30 degrees south. All right. So that's how latitude is done. And the limit for latitude is it can be anywhere between 90 degrees south through to 90 degrees north. The reason why it's 90 degrees is, that's like the North Pole and that's the South Pole. And then if you go past that, then you could just go on the other side of the Earth. So latitude is between 90 degrees south and 90 degrees north. And then for longitude, so longitude is similar concept, except we're thinking about vertical lines. So it's a terrible circle, but like there's a place in England called Greenwich, and that's kind of, we draw a line going down it. And then so that's UTC 0, that's 0 degrees. And then anything to the right of it is east, anything to the left of it is west. And then so the idea is if I had another point here, for instance, so we'd think about the angle between those two things. Like if you drew a cross section of it, you'd think about the angle. So this is in a westerly direction. Maybe it could have been like 60 degrees or something. So we'd say that that's 60 degrees east. So a bit of a terrible drawing. And the range for this is 180 degrees west and 180 degrees east. So at 180 degrees west and east, that's actually the same point, and that's the international date line. So keep that in mind as well. Now, one other thing that I'll just mention when talking about latitude and longitude and all that stuff, if you're trying to find the difference between those, general rule of thumb I say is if we're trying to find the difference in longitudes, if it's on the same side, you subtract. If it's on different sides, you add. A bit of an easier way to think about it is like if we think about a compass. So you've got north, south, east, west. Okay. If you would kind of consider this as a number plane, we would say that these all are positive numbers and these are all negative numbers. So, and then these are all positive numbers and these are all negative numbers. So what I kind of tend to do is if I'm considering 20 degrees south and maybe 30 degrees north, and I'm trying to find the difference in latitude between those two, I'll do 20, seeing that they're opposite sides, I'll do 30 plus 20. But the other way that you could do it as well is you could think of south as negative 20 because it's in the negative region of that Cartesian plane, if you were to think about it as a number plane. And similarly with west, if I had, so that could be like negative 20 degrees because it's south. Or if I had like 100 degrees west, I could consider it as negative 100 degrees east or something like that. So, that might be helpful as well. In any case, what you need to do, as it says here, is you need to be able to find the difference between latitudes and longitudes. So just realizing when you need to add and when to subtract is important. Anyway, so now that I've rambled on for a bit here, let's do some past HSC questions. So this first one here, we have Kim lives in Perth, and he wants to watch an ice hockey game being played in Toronto at 10 p.m. on Wednesday. What time on Earth, what is the time in Perth when the game starts? So in this question, and this is like an old syllabus, so this is back when, it was a lot more about calculating the difference between longitudes, but I figured I'd just focus on that. So the first thing we'll want to do here, because we don't have the time zones, is we need to figure out the time difference between these two places. So what we need to do first of all is find the longitudinal difference. So longitudinal difference. And so what we're saying is like we need to find what's the difference between 115 degrees east and 80 degrees west. So what I was saying previously is east and west, they're different sides. So just add. So 115 degrees plus 80 degrees equals 195 degrees. So we're told, we've now figured out there's 195 degrees difference in the longitude. So now from that, we can get our time difference, because remember we said every 15 degrees longitudinal difference is 1 hour. So therefore time difference equals 195 divided by 15, and that equals 13. So that means it's a 13-hour time difference between these two places. Now that we've got that, the last thing we need to do is figure out, well, answer the question. We need to do a time change. And so this is where I've talked about in the past. I think it's always useful to draw a number line for this. So we have Toronto at 80 degrees west, and we have Perth at 115 degrees east. So Perth is like the most easterly one. So I've got Perth, and that's at 115 degrees. And we have Toronto, which is at 80 degrees west. So I'm going to consider that as negative 80, all right? Or I could write this 80 degrees east, 80 degrees west. But what I'm saying here is, like, here's 0. So anything left of 0 is negative, everything right is positive. So now we're saying this game is starting at 10 p.m. on Wednesday. So we're saying that we have the time in Toronto. I want to change to the time in Perth, and that's what the question's asking. So now that we've got this number plane, we're saying we've got the time here, so I want to change it to be Perth time. And so here, if we're thinking about this as a number line, we're going in the right direction. So if we're going right, I'm going to add that 13-hour time difference. If I started in Perth and I was going to Toronto, that means I'll subtract that 13-hour time difference because I'm going to the negative direction. So we have this 10 p.m. Wednesday. First thing we need to do is it's always best to convert that to 24-hour time. So 10 p.m. is 22 o'clock. But for the purpose of calculations, we're going to write that as 22 degrees, 0 minutes, okay? And then so here we got 22 o'clock, and we want to add that 13 hours because I'm going to the right. So we're going to add 13 degrees, 0 minutes, and that equals 35 degrees. That's basically saying 35 o'clock. Now, of course, 35 o'clock doesn't exist. We have 24 hours. So whenever these times exceed 24 hours, what you do is you subtract 24 hours from that and then go to the next day. So we're seeing that this is on Wednesday. So that means we've gone so far out of Wednesday, we're now on Thursday. So therefore, we're going to do 35 degrees, 0 minutes, minus 24 degrees, 0 minutes, which equals 11 degrees, 0 minutes. So therefore, we have 11 a.m. because 11 o'clock is 11 a.m. We know it's a.m. because it's less than 12. But because we had to do that subtraction of 24 hours, we've gone forward a day. So it's 11 a.m. on Thursday. Answer is D. All right, going on to the next question, and I forgot to mention this in the previous one, but what you should be doing as you're going through these videos is pause the video, have an attempt at the question, and then watch the solution afterwards just to see how you go. So this question is actually quite similar in the fact that we're given two places, and these are the kind of common questions. These are the ones that you want to make sure you understand completely because it's really all it will ask in the HSC, I would say. So Cassie flew from this place, so London to Manila. And then we have this, her plane left London at 9:30 a.m., stopped for 5 hours in Singapore, and arrived in Manila at 4 p.m. Tuesday, Manila time. So what was the total flying time? And we need to ignore time zones. And I think that ignore time zone is a bit of a throw-off, but, whatever. So what we need to do, first of all, is half of this is in London time and half of this is Manila time. That's not helpful. We need them to be in consistent time zones. So what I'm going to do is I'm going to change this London time, 9:30 a.m. on Monday, to be in Manila time. Because if I'm focusing only on Manila time, I only need to think about the breaks, and then that's good to go. So to change the time, I need to first find the time difference between these two places. So we see that London is 0 degrees east and Manila is 120 degrees east. So that means the longitudinal difference, just like in the previous question. So longitudinal difference is equal to 120 minus 0. So pretty easy, 120 degrees. And therefore the time difference, using again that idea of every 15 degrees is 1 hour time difference. So 120 divided by 15 is 8 hours. So we've got an 8 hour time difference. Now, like what we did in the previous question, the next thing we need to do, now that we know that there's an 8 hour time difference, to actually change that London time into Manila time, I suggest, drawing up a number line. So London is the most east one. Is the most west one. So we've got London here and we have Manila here. This is at 0 degrees and this is at 120 degrees. So there's no negatives this time because there's no west. Again, the idea is I want to change the London time into Manila time. So I'm starting at London, going in this direction. So that means I'm going in the right direction on the number line. I'm adding that 8 hours. So I have 9:30 a.m. So 9 degrees, 30 minutes, plus the 8 hours. And that equals 17 hours, 30 minutes, which is 5:30 p.m. on Monday, Manila time. So what we're saying is this plane that left at 9:30 a.m. on Monday converts to be 5:30 p.m. on Manila. So it's still at the same time. And so now what we need to do is we're trying to find what's the total flight time. Okay. So the plane left at 5:30 and then it arrived at 4 p.m. the next day. So let's first find it left at 5:30 p.m. on Monday and it arrived at 4 p.m. on Tuesday. So the first thing we want to do is find the total time difference in this whole trip. So now what we're going to do, this 4 p.m. Tuesday, you might be able to just tell, okay, from 5:30 p.m. on Monday to 4 p.m. on Tuesday, that's 22 and a half hours, which it is. What I guess you could also do is 4 p.m. on Tuesday could be kind of considered as 40 hours. Like 40 o'clock. The reason why I do that is 4 p.m. is 16 o'clock, right? So if it's on Tuesday, I can then add another 24 hours. And then so if I do 40 minus 17 degrees, 30 minutes, that would equal 22 degrees and 30 minutes. So that's one way of doing it, but it might just be a bit more intuitive to just think, well, if we left at 5:30 and we arrived at 4 p.m. the next day, that's 22 hours and 30 minutes. Journey time. But again, the question isn't asking, well, how long was the whole journey? How long was the total flying time? So we're told in the question that it stopped for 5 hours in Singapore. So therefore, we're just going to subtract 5 hours from that. So 17 hours and 30 minutes flying. Because we just took away those 5 hours of waiting time in Singapore. All right. Hopefully you're seeing that this is kind of coming down to the same idea. We've got a longitudinal difference, and sometimes like it could have just as easily said, this is UTC 0 and this is UTC 8 or plus 8. And if the question said that, well, then you can figure out the exact same thing as an 8 hour time difference. All I'm saying is it might just give you the longitudes and you'll need to find the longitudinal difference and divide by 15 to get that instead. All right, and then going into this next question, I've got two more. This one is, again, very similar to the previous one, so I might go through it a bit faster. But I've chosen this one because it's got a weird thing to it. So we have these two places, Buenos Aires and Adelaide. And so what is the time difference between Adelaide and Buenos Aires? So time difference is based on longitude. So we have 60 degrees west and 140 degrees east. Again, east-west, they're on different sides. So we're going to add. So the longitudinal difference is 60 plus 140, which equals 200 degrees difference. And then, so now what we're going to do is do 200 divided by 15. So therefore, time difference And when you put 200 divided by 15 into your calculator, you're going to get 13.33333 ... This, to be very, very clear, and this is why I chose this question, this is not 13 hours and 33 minutes. It's not, because this is decimals, but remember, we want to work with degrees and minutes. So if you just do your, so if I get that 200 divided by 15, I get 13.3333. That's not 13 degrees and 33 minutes. I then press the degrees, minutes, seconds button, and I get 13 minutes and 13 hours and 20 minutes, which is correct. So 13 hours and 20 minutes. Now, the other weird thing about this question is this isn't how time zones work. Like, it's not completely based on longitudinal difference. So it's not like there is actually a 13 hours and 20 minute difference. Time zones work in that they're blocks of 15 degrees difference, just so it saves you having minute differences. Otherwise, you might find like this place is 7 minutes ahead of the other place. It would not really work practically in the world. This is why the question also says ignore time zones. So based on the longitude only, we'd say that this is 13 hours and 20 minutes, but in real life, it's probably just 13 hours or maybe 14 hours. Depends on the Greenwich mean, the UTC boundaries. Not needing to go into too much of that. This is back in 2002, so it's a bit of a weird question, but what we're saying is based on the longitude, it's 13 hours and 20 minutes difference. And then part 2. So Roy lives in Adelaide and his cousin Juan lives in Buenos Aires. Roy wants to telephone Juan at 7 p.m. on a Friday night, Buenos Aires time. At what time and on what day should Roy make the call? So again, we're doing the time difference question. So draw a number line. And then so Buenos Aires is the most west one. So we have this, and I'm going to write that as -60 because it's west. You don't need to again, but I just do. And then we've got Adelaide, and that's 140. And I'm just going to put 0 there. The 0 doesn't really make too much. It's not important, but it's just kind of saying, that's 0. And again, so we're saying that wants to phone them at 7 p.m. on a Friday night, Buenos Aires time. So that means we have that time, and I want to change the Adelaide time. So again, unfortunately, the past 3 questions have all been adding, but whatever. So we want to make this at 7 p.m. So 7 p.m. is 19. We've got 19 hours, 0 minutes. And we found out that there's a time difference of 13 hours and 20 minutes. So plus 13 hours, 20 minutes. And that equals 32 degrees, 20 minutes. And then again, this is above 24. So what we do is we'll subtract 24. So therefore we get 8:20 a.m. But because I subtracted 24 and that was on Friday night, the subtracting 24 means I go forward a day. So this is 8:20 a.m. on a Saturday. Okay, and the question is saying at what time and what day. So if the question is asking you what day, make sure you say what day. That's what the 2 marks are for. 1 mark for the time, 1 mark for the day. Okay. And then lastly, so looking at this question, and this, I picked this question, and I know I kind of want to focus on HSC questions, but I think it's worthwhile we look at a timetable question, and this was a good one for it. So this is from the 2019 CSSA paper. So Beck travels by train and bus from Strathfield to Macquarie University via Hornsby. What that means is they're starting at Strathfield, going to Hornsby, and from Hornsby they're going to Macquarie Centre. So that's what via means. So Beck leaves Strathfield on the first train after 15 p.m. And with these train and bus timetables, they're always going to be in 24 hours. So, this is 17 o'clock. So including the shortest possible waiting time between the train and the bus, how long was the journey? So we're saying that we want to catch the first bus from Strathfield after 17 o'clock, which is this one. Okay, so make sure you're looking at the Strathfield row. We're not catching the train from Central, we're catching it from Strathfield. So we're catching the 5:03 train, and then that arrives at Hornsby at about 5:28 p.m. or 1728. And so now that we're at Hornsby, we want to catch a bus to Macquarie University, and we'll catch the first one that we can. So looking at Hornsby, no, we can't catch that one, can't catch that, but we can catch that because that's at 5:30. We're arriving at 5:28. So we can catch that train, bus, and we want to get to Macquarie University. So we're getting at Macquarie University at 6:49 p.m. So what we now need to do is see how long a journey was. And this is kind of like a interesting little bit to it. So I'm like, because it's a multiple choice, I know what it is, but you're kind of asking, the idea is we want to get the first train at after 5 p.m. So we caught that at 5:03. So it's like, well, do we count that 3 minutes that we had to wait for that first train? Who knows? I guess not. Anyway, all we need to do now is find the time difference between 6:49 p.m. and 5:03 p.m. So what we'll do here is we've got 18:49 minus 17:03. So 6:49 minus 5:03, and that equals 1 hour and 46 minutes. All right. So that question, there could just as easily be a question on timetables, bus and train timetables, because that is in the syllabus. And all those kinds of questions come down to is making sure you look at the left to see what station or bus stop you're at, and then making your way down, being aware of 24-hour time. Anyway, hopefully this video has been useful. If you have any more questions about this topic, be sure to ask. Thank you.